It is possible that the insulation on the service entry conductors is peeling due to exposure to sunlight. This can happen even if the conductors are rated for outdoor use, as the sun's rays can eventually break down the insulation. Another possible cause of the insulation peeling is that the conductors were not properly installed. If the conductors were not tightened properly, they may be able to move around in the weatherhead, which can cause the insulation to rub against the weatherhead and eventually peel off. Whatever the cause, it is important to have the insulation repaired as soon as possible. Exposed conductors can be a safety hazard, as they can cause electrical shocks or fires. Firstly, turn off the power to the house at the main breaker. Secondly, remove the weatherhead and inspect the conductors. Thirdly, if the insulation is peeling, use electrical tape to wrap it tightly around the conductors. Make sure that the tape is overlapped by at least 50%. Fourthly, reinstall the weatherhead and turn the power back on. To elaborate on the potential causes and solutions, let's delve into the specifics of conductor insulation, sunlight resistance, and proper installation techniques. Sunlight, particularly ultraviolet radiation, is a significant factor in the degradation of many materials, including the insulation used on electrical conductors. Even conductors labeled as sunlight resistant are not immune to the effects of prolonged exposure. The rate at which the insulation deteriorates depends on several factors, including the intensity of the sunlight, the ambient temperature, and the specific composition of the insulation material. Some types of insulation are inherently more resistant to ultraviolet degradation than others. For instance, cross-linked polyethylene, or XLPE, is often used for service entrance conductors because of its superior resistance to heat, moisture, and ultraviolet radiation compared to some older insulation types. However, even XLPE will eventually degrade over time when exposed to direct sunlight. The process of degradation typically begins with the surface of the insulation, causing it to become brittle and crack. This can lead to the peeling or flaking observed on the conductors. The rate of degradation can be accelerated by other environmental factors such as pollution, salt spray, and extreme temperature fluctuations. When selecting conductors for outdoor use, particularly in areas with high levels of sunlight, it is crucial to choose conductors that are specifically listed and labeled for sunlight resistance. The National Electrical Code, or NEC, provides guidelines for the selection and installation of conductors, including those used for service entrances. The NEC requires that conductors be suitable for the environmental conditions in which they are installed. This includes exposure to sunlight, moisture, and temperature extremes. In addition to selecting the appropriate conductors, proper installation techniques are essential to prevent premature insulation failure. As mentioned earlier, loose connections can cause the conductors to move and rub against the weatherhead or other components, leading to abrasion and eventual peeling of the insulation. It is important to ensure that all connections are properly tightened and that the conductors are adequately supported to prevent movement. The weatherhead itself should also be inspected to ensure that it is in good condition and does not have any sharp edges or protrusions that could damage the insulation. Furthermore, the method of attaching the service entrance conductors to the weatherhead should be carefully considered. Some weatherheads use compression connectors, while others use set screws. It is important to follow the manufacturer's instructions for the specific type of connector being used to ensure a secure and reliable connection. When repairing damaged insulation, it is crucial to use electrical tape that is specifically designed for this purpose. Electrical tape is typically made of a vinyl or rubber material and is coated with an adhesive. It is important to choose a tape that is compatible with the type of insulation being repaired and that is rated for the voltage and temperature of the application. When wrapping the tape around the conductor, it is important to apply it tightly and to overlap each layer by at least 50%. This will help to ensure a watertight seal and to prevent moisture from entering the insulation. In some cases, it may be necessary to use multiple layers of tape to provide adequate protection. In addition to electrical tape, there are other methods of repairing damaged insulation, such as using heat shrink tubing or liquid electrical tape. Heat shrink tubing is a plastic tube that shrinks when heated, providing a tight and durable seal around the conductor. Liquid electrical tape is a paintable coating that can be applied to the conductor to provide insulation and protection. These methods may be more suitable for certain applications, such as repairing insulation in tight spaces or in areas where it is difficult to apply electrical tape. However, regardless of the method used, it is important to ensure that the repair is performed correctly and that the insulation is adequately protected. If the damage to the insulation is extensive, it may be necessary to replace the entire conductor. This is a more costly and time-consuming repair, but it may be the only way to ensure the safety and reliability of the electrical system. When replacing conductors, it is important to use conductors that are of the same size and type as the original conductors. It is also important to follow all applicable codes and regulations. Finally, it is important to note that working with electricity can be dangerous. If you are not comfortable working with electricity, it is best to hire a qualified electrician to perform the repair. An electrician will have the knowledge and experience to safely and effectively repair the damaged insulation. In addition to addressing the immediate problem of peeling insulation, it is also important to take steps to prevent future occurrences. This may involve relocating the service entrance to a location that is less exposed to sunlight, installing a sun shield to protect the conductors, or using conductors with a more durable insulation material. By taking these precautions, it is possible to extend the lifespan of the service entrance conductors and to prevent future insulation failures. The information provided is intended for general guidance only and should not be considered a substitute for professional advice. Always consult with a qualified electrician or other professional before performing any electrical work. To reiterate, the peeling of insulation on service entry conductors can stem from several factors. Exposure to sunlight is a primary culprit, even in conductors designed for outdoor use. The ultraviolet rays and sunlight gradually break down the insulation material, causing it to become brittle and flake off. Improper installation techniques, such as loose connections at the weatherhead, can also contribute to the problem. When conductors are not securely tightened, they can move and rub against the weatherhead, leading to abrasion and eventual insulation failure. The NEC mandates the use of conductors suitable for their intended environment, considering sunlight, moisture, and temperature. Sunlight-resistant conductors are essential for outdoor applications, especially in regions with intense sun exposure. Moreover, proper insulation practices are crucial. Connections must be tight to prevent conductor movement and abrasion. The weatherhead itself should be inspected for any sharp edges that could damage the insulation. When repairing damaged insulation, electrical tape specifically designed for this purpose should be used. The tape should be applied tightly, with a minimum overlap of 50% to ensure a watertight seal. Alternative repair methods include heat shrink tubing and liquid electrical tape, which may be suitable for certain situations. In cases of extensive damage, conductor replacement may be necessary. When replacing conductors, it's vital to use the same size and type as the originals and adhere to all applicable codes. Working with electricity can be hazardous. If you lack the necessary skills or experience, it's best to hire a qualified electrician to perform the repair safely. The NEC contains various articles relevant to service entrance conductors and their installation. Article 230 covers service entrances, including the types of conductors permitted and the requirements for their installation. Article 310 deals with conductors for general wiring, including their insulation types and ampacity ratings. When selecting conductors for a service entrance, it is important to consider their ampacity, which is the maximum current they can safely carry. The ampacity of a conductor is determined by its size, insulation type, and the ambient temperature. The NEC provides tables that list the ampacity of various conductors under different conditions. It is also important to consider the voltage drop of the conductors. Voltage drop is the decrease in voltage that occurs along the length of a conductor due to its resistance. Excessive voltage drop can cause appliances to malfunction and can even damage electrical equipment. The NEC provides guidelines for calculating voltage drop and recommends that voltage drop be limited to a certain percentage of the supply voltage. In addition to the NEC, local codes and regulations may also apply to service entrance conductors. It is important to check with the local authorities to ensure that all applicable codes are followed. When installing service entrance conductors, it is important to use the proper tools and equipment. This includes a wire stripper, a crimping tool, and a torque wrench. A wire stripper is used to remove the insulation from the conductors without damaging the wire. A crimping tool is used to crimp connectors onto the conductors. A torque wrench is used to tighten connections to the proper torque. Using the proper tools and equipment will help to ensure a safe and reliable installation. After the installation is complete, it is important to inspect the service entrance to ensure that it is properly installed and that all connections are tight. This includes checking the weatherhead, the conductors, and the grounding system. A thorough inspection will help to identify any potential problems and to prevent future failures. Finally, it is important to maintain the service entrance to ensure that it continues to operate safely and reliably. This includes periodically inspecting the conductors for signs of damage and tightening any loose connections. Regular maintenance will help to extend the lifespan of the service entrance and to prevent costly repairs. Furthermore, the choice of conductor material also plays a crucial role in its overall performance and longevity. Copper and aluminum are the two most commonly used conductor materials in electrical wiring. Copper is known for its excellent conductivity, corrosion resistance, and ductility. Aluminum, on the other hand, is lighter and less expensive than copper, but it has lower conductivity and is more prone to corrosion. When using aluminum conductors, it is important to use connectors that are specifically designed for aluminum and to apply an antioxidant compound to prevent corrosion. The antioxidant compound helps to create a tight seal between the conductor and the connector, preventing moisture and air from entering. In addition to the conductor material, the type of insulation used also affects its performance. Thermoplastic high-heat nylon, or THHN, is a common type of insulation used for general wiring. THHN insulation is resistant to heat, moisture, and oil. Cross-linked polyethylene, or XLPE, is another type of insulation that is often used for service entrance conductors. XLPE insulation is more resistant to heat and moisture than THHN insulation. When selecting insulation, it is important to consider the environmental conditions in which the conductors will be installed. In wet or damp locations, it is important to use insulation that is rated for wet locations. In high-temperature locations, it is important to use insulation that is rated for high temperatures. The NEC provides tables that list the temperature ratings of various types of insulation. The grounding system is another important component of the service entrance. The grounding system is designed to protect people and equipment from electrical shock. The grounding system consists of a grounding electrode, a grounding conductor, and a bonding conductor. The grounding electrode is a metal rod or plate that is buried in the ground. The grounding conductor connects the grounding electrode to the electrical panel. The bonding conductor connects the metal parts of the electrical system to the grounding system. The grounding system provides a low impedance path for fault current to flow back to the source, causing the circuit breaker to trip and to energize the circuit. It is important to ensure that the grounding system is properly installed and maintained. The NEC provides detailed requirements for grounding systems. In addition to the grounding system, surge protection is also important to protect electrical equipment from damage caused by voltage surges. Voltage surges can be caused by lightning strikes, power outages, and other electrical disturbances. Surge protection devices, or SPDs, are designed to divert excess voltage away from sensitive electrical equipment. SPD are typically installed at the service entrance and at individual circuits. It is important to select SPD that are rated for the voltage and current of the electrical system. The NEC provides guidelines for the selection and installation of SPD. By taking these steps, it is possible to protect electrical equipment from damage caused by voltage surges. Remember that this explanation is for informational purposes only. Always consult a qualified electrician for any electrical work or repairs. The complexity of electrical systems necessitates expertise to ensure safety and compliance with regulations.